Question 1b is about the risks from radon gas. So the 50% of background that comes from radon gas presents a significant risk in some places in the country. So the first part says that each year 1,000 to 2,000 people die because of the effects of radiation from radon gas. And it asks you why it's not possible to nail that figure down more. So why is it 1,000 to 2,000? Why isn't it exactly 1,600 people? Well, the reason for that is that you can't necessarily tell what the cause of death might have been. There could be a load of other factors involved. So it's all you had to say. Other factors may be involved. Specific suggestions of other factors would be okay, that they might have been exposed to a different type of radiation, or that you can't tell that it's definitely radon that's causing the deaths. That was also fine. Okay, next part, we're going to need to look at this table. Now, whenever you get a table, it's really important that you look carefully at the column headings and what information you've been given. Now, some of the things on here are a little bit confusing. The units for this average radiation level, for example, you won't be expected to know or recognise that. That's just in there for completeness. And you don't need to know what that means in order to answer the question, that becquerels per metre cubed there. Okay? So, give one reason why the measurements were taken over 3 months using detectors in different rooms. Well, you could focus on the different rooms part and say that there might be different concentrations of radon in the different rooms. Or you can focus on the 3 months part and say, well, there might be variations or fluctuations from day to day. So we want to be able to find an average, or to make the results more reliable or valid. Accurate on its own, though, is not enough. Okay? If you say reliable or valid on their own, that's fine. Reliable, remember, meaning that you can kind of trust that the result is going to be the same if you do the experiment again. And valid, meaning that the result is a good reflection of what's actually happening in that house. So is it actually a good reflection of the radon levels that are going to be in the house? So, averaging out daily fluctuations or different concentrations might be in different rooms. It then says use information from the table. So if it says that, you must make sure that you do use some information from the table. Sometimes it's a good idea to quote some figures from the table, because then you'll have to use the information. So suggest using information from the table why a much higher proportion of homes were sampled in areas C and D than in areas A and B. Well, if we're looking at risk from radon and you look at areas C and D, you can see that the average radiation levels are much higher. So that's the first point. Okay, the average level's much higher in C and D. When it says accept the converse, that means it's fine if you said the average levels are much lower in A and B. So that's the average level. It also wants you to mention the maximum level, and this is in some ways more important. If you imagine that you're living in a house in C and D, what this means is that some houses in area C and D have massively higher levels of radon. Now, you're not going to know which ones it is necessarily unless you sample a very large number. So the real main reason for the large number of samples is because some houses have very, very high levels, and it's important to find out what those are. Okay, so the maximum level in some homes in C and D is very, very high, is the second mark there. And that's it for out of 7 now.